Hello and welcome to section 8.3, Laws of Logarithms. I am going to leave the exploring the laws of logarithms up to you to do on your own. The instructions are pretty explicit in there, so you can notice the trends as you go through and then do the reflect and respond. But we will start here with the laws of logarithms. Laws of logarithms. Okay. So log base c of m times n. Now this can also be written as the sum of two logarithms with the exact same base. So log base c of m plus log base c n. So you can take these logarithms separately and write them as a sum. Similarly, for a quotient, logarithm of a quotient, these can be written as a difference. So log base c m minus log base c n. So the numerator is the one that comes first, so log m, since m is on top, subtract log base c n. And finally, the logarithm of a power. Now the logarithm of a power, we can just write by taking the exponent and multiplying it as a coefficient of the regular logarithm of whatever base was here. So we have p times log c of m. Now let's get a little practice applying some of these laws here. Using the laws of logarithms to expand expressions, so writing each expression in terms of individual logarithms of x, y, and z. So log base 5 of x, y over z. Okay, so first we apply the product law here, and log base 5 of x times z, x times y, would be log base 5 of x plus log base 5 of y. And finally, the z is what we're subtracting everything by, what we're dividing everything by, so we subtract that as our final one here. So let's double check and see how we did. Perfect. Alright, let's move on to the next one. Log base 7 of the cubed root of x. So first what I'm going to do is I'm going to rewrite the cubed root of x as x to the 1/3. Now you see this now becomes a power problem. We can rewrite this log base 7, and this is now m to the, as we did on the last page. So the m, as we know, goes out front. That can be written as 1/3 log base 7 of x. So the next one, log base 6 of 1 over x squared. I am going to rewrite my 1 over x squared as x to the minus 2. So now we have log base 6 of x to the minus 2. So again, m to the p, this p can come out front as a multiplicative factor, -2 log base 6 of x. Done. Now, d. We got a lot going on here, so I'm going to rewrite each one of these. So, going to rewrite the numerator, log base 10 x cubed. Now we assume base 10 because it's not explicitly stated. Now, the denominator, we are going to subtract the entire denominator, but the denominator is a product of y times root z. So, the first one would be the log of y, and since these two are multiplied together within the denominator, I'm going to add them to each other. But again, we're subtracting the whole denominator. We'll see how that comes into play later. So root z can be written as z to the 1/2. Alright, now let's simplify this a little bit. M to the p, so that p comes out front. This is 3 log x. minus log y. No simplification we can make here. That negative will get distributed here as well, so that becomes a minus. And this exponent we can drop out front and write as 1/2 multiplied by the log of z. And we're done. So I'll leave it up to you to do the your turns on your own. So hit pause now. And here are the solutions to the your turns. So if you're able to come to those same answers, then give yourself a hearty pat on the back. Okay, now, forgot to clear this. Okay. So we're going to work backwards this time. So we're starting with 3 separate terms, and we're going to use the laws of logarithms to combine these terms and find a simple answer to each one of these things. So A, log base 6 of 8 plus log base 6 of 9. Now, since they are added, these two things, the 8 and the 9, can be multiplied together, and we can rewrite this thing as log base 6 of 8 times 9, which is 72. And since this second log, or third log here, is subtracted, since it has the same base, they're all base 6, subtracted, we can write this as the denominator in the quotient of a log. So this becomes log base 6 of 72 over 2, which is 36, which means what? 6 to the power of what equals 36, and you can see by inspection that the answer is 2. So we turn something that looks rather complicated into something very simple, and we find that it has a whole number answer as well. So the next one, log base 7 of 7 root 7. Now these two things are multiplied together. We can separate them by writing it as log base 7. Since they're multiplied together, we can rewrite this as plus log base 7 of root 7, which is 7 to the 1/2. Now again, 7 to the 1/2, we can take this exponent and rewrite it as a multiplicative coefficient in front of the log. And now we have something that turns out to be quite simple. 7 to the what equals 7. You find out that the answer here is 1. And then 1/2 times 7 to the what equals 7. And that would be 1/2 times 1. So we have 1 plus 1/2, and your answer is 1.5 or 1.5. However you choose to represent it is fine. Alright, the last one. The last one looks like an absolute mess. Let's see what we can make of it here. 2 log base 2 of 12. Now, we can also work backwards on these power ones. So we could rewrite this as log base 2 of 12 to the 2, which is 144. Let's see if that helps us later. Now this negative sign is going to apply to both of these things, but let's see if we can simplify within the brackets first. These are both written as a log base 2. So log base 2, 6 plus, now this we can toss up as an exponent on the 27. So 27 to the 1/3. And 27 to the 1/3 is the cubed root of 27. Now the cubed root of 27 is 3. So this whole thing can be written as log base 2 of 3. Now since these two things are added together, we can rewrite them as log base 2 as a product of 6 times 3, which is 18. And we are going to subtract this thing from log base 2 of 144. So log base 2 of 144 minus log base 2 of 18 is log base 2 of 144 divided by 18. And you can do 144 divided by 18. Okay, let's try that again. 144 divided by 18, and you get 8. So we rewrite this whole thing as log base 2 of 8. 2 to the what power will give you 8, and you can see by inspection that the answer is 3. Okay, so here's the your turn. You can go ahead and try those out on your own, and when you're done, you can unpause it and get the answers. So hit pause. There you go. There's your answers. So hopefully you were able to find those. All right. This next one, write each expression as a single logarithm and state the restrictions on the variable. Now, the restrictions on the variable, let's take a look at these first. We are not allowed to take the log of 0 or a negative number because there is no statement, let's say our base is 7, there is no y value in the world that will make this true. Nothing. 7, there's nothing that you can raise 7 to the power of that will make this thing 0. Similarly, there's nothing you can raise 7 to the power of to make this thing negative. So you must always take the log of a positive number, meaning x has to be greater than 0. Here, x has to be greater than 0. X here and x here all have to be greater than 0. So that is our restriction on the variable. Now let's figure this out. We want to write it as a single log in simplest form, log base 7x squared plus log base 7x. Now we can easily put those two together because of this plus sign here. So we go log base 7x squared, and then because it's plus, we multiply those things together. And then we're going to subtract this whole thing, and I'm going to rewrite this as 5 halves times log base 7 of x. Okay, so this is log base 7 x cubed. Now this thing we can write as log base 7, and we can take this coefficient, this multiplicative coefficient, toss it up here as an exponent, and rewrite this thing as log base 7 x to the 5 halves. Okay, now we're subtracting a log from another log, so we can write these as a quotient. So we have log base 7 x cubed divided by x to the 5 halves. Okay, now x cubed divided by x to the 5 halves is x to the 3 minus 5 halves. 3 can be written as 6 halves, and we're subtracting 5 halves, which gives us x to the 1 half left. Now that is root x, but we're going to leave it as x to the 1 half, so we can toss it as a multiplicative coefficient out front, and we get 1 half log base 7 x, and that is our simplest form. So let's take a look at the next one then, and notice that these are all in base 5. So the first thing we want to do, see if we can rewrite these as a quotient because of this negative sign here. So log 5, base 5 of 2x minus 2, all divided by x squared plus 2x minus 3. Now, let's find some restrictions on the variable first. This can't be 0 or less than 0, whatever we're taking the log of. So 2x minus 2 must be greater than 0, meaning 2x must be greater than 2, and x must be greater than 1. That is one of our restrictions. Now we have another restriction here. We're going to have to factor this to figure out. We're actually going to have 2 restrictions here because this is a quadratic with 2 roots. So we can't take the log of something less than 0, so we go x squared plus 2x minus 3 must be greater than 0, meaning x, and this will be plus 3 times x minus 1 must be greater than 0. So that means you can set x can't be minus 3 and x cannot be positive 1, or sorry, must be greater than those things. Okay, so we have all those, which basically means x must be greater than 1 in general. And so let's finish up this one here. Now we saw that this one can be factored as x plus 3 times x minus 1. The numerator can also be factored, so log base 5. Numerator, take out a factor of 2, we're left with x minus 1. Denominator, x plus 3 times x minus 1. And of course, those will cancel. Now we're left with log base 5 of 2 over x plus 3. And that's it. So we're done that one. Okay, so here's your turn. Go ahead and give it a try. So hit pause, the answers will be there when you get back. There you go, there are the answers. Hopefully you were able to identify those and start to get an understanding of what's going on here. I'm going to save this one. We're going to solve this one together later. So that's it for today's lesson, and I'll see you in class tomorrow if you do end up watching this tonight.